Hello guys, welcome to the mathematics lesson. In today's mathematics lesson, we are going to continue from where we ended, and the topic we are looking at is still probability, and in today's subtopic we'll be looking at tree diagrams. Alright, so you must understand what it is when we talk of tree diagrams in probability. So we are saying these are diagrams on which the possible outcomes of events are written at the ends of the branches. Yeah. So tree diagrams are just branches, okay, at the end of which the possible outcomes are written. Okay. So tree diagrams are rather diagrams on which the possible outcomes of events are written at the ends of branches. It means that in a tree diagrams you have branches, and on those branches are where we represent the possible outcomes of events. All right, so you will understand very soon as I present this example here. All right, so we have this example which says a bag contains 2 red beads and 3 white beads. A bead is picked at random from the bag and replaced in the bag. Then a second bead is picked from the same bag. Okay. Then B says a bag contains 2 red beads and 3 white beads. A bead is picked at random from the bag and is not replaced in the bag. Then a second bead is picked from the same bag. Then they're saying the information above can be shown below. So this information which we have here can be actually be shown on a tree diagram. Okay, so let's start with the M, where I'm going to show you this information on a tree diagram, where we should show the possible outcomes of these here. Okay, so let's move here. Let's say solution. So here, what you need to take note is this, that number one, in this scenario, after each draw, the bead is replaced back into the bag, so the total number of beads remains the same for both rows or draws. Okay, so we are told we have 2 red beads and 3 white beads in a bag, right? And the bead is picked at random from the bag and replaced in the bag. Okay, meaning that you have in the same bag 2 red beads and 3 white beads. Total together of the total number of beads which are in the bag is actually 5. Okay, so when you pick a bead from the bag and replace it, meaning that the total number of beads remains the same. The total number of red beads and then the total number of white beads remains the same. Okay. Then we're saying then a second bead is picked from the same bag. So also the second pick and the first pick have got almost the same probabilities. Why? Because in the first instance, when a bead is picked for the first time, it is replaced back in the bag. And then for the second pick also, the CC, the number of beads is not affected because the first bead was replaced back, meaning the probability also will be the same in the second pick. That's why we are saying in this scenario, after each draw or picking, the bead is replaced back into the bag, so the total number of beads remains the same for both draws. So here we are saying for the first draw, there are 5 possible outcomes, 2 red and 3 white beads. Okay, yeah. So for the first draw, we have what? Total possible outcome is 5, which comes from adding 2 red beads and 3 white beads. Now for the second draw, there are still 5 possible outcomes as the bead is replaced. So even in the second picking or draw, we still have 5 possible outcomes because the first bead which was picked was replaced back. Now, if we were to represent this information on a tree diagram, it would be like this. Like, since we have how many types of beads? We have red and white. So we can have two branches to represent these ones here for the first pick. So for the first pick, you can either, when you pick for the first pick of a bead, the bead can either be red or it can be white. Okay? So this one we are calling it the first draw. So you pick for the first draw. You draw or you pick the first bead. So that bead that you pick first, it can either be red or white. Okay, now what is the actual probability that that bead which is picked for the first pick is red? Okay, you just look at the number of beads which are there, which are red. There are 2 red beads there, and the total number of beads is actually 5. So the probability that the bead which will be picked for the first pick is red here, it will be actually 2 over 5. Okay, 2 is the number of red beads, and 5 is the total number of beads when you add 2 plus 3. Then the probability also that if for the first pick the bead was actually white also follows the same pattern. Since you have 3 white beads and the total number of beads is 5, so the probability that the first pick which was done, the bead was white, is still 3 over 5 there. Now, there is the second pick of the bead, all right? So here we'll write 2 branches here and also here 2 branches, okay? So for the second pick, if the first pick which was done was red, then for the second pick, again, which is done here at the red branch here, since the bead was replaced, okay? In the first instance here, the bead was replaced. Then you pick for the second time. So the probability that if you picked for the first time, the bead is red here. And here we are saying we have white, okay? Here also red, here also we have white. So the probability that here it will be red, the actual probability, okay, is that of the same, because the bead was replaced back in the same bead, so in the same bag. So if you pick for the second time, the probability that it will be red is still the same. So it is still 2. So this is for the second draw here. So the probability is still 2 over 5. Also that maybe the pick was actually white is still the same. Since the bead was replaced, it is still 3 over 5. And here it is still 2 over 5, and here it is still 3 over 5 because the ball was replaced back. So we can say the outcome on red picking here, it will be red, red here, red, red. Okay, so this route up to here, the outcome of it is red as red, red. Then this route from here up to here, its outcome is red as red, white, red, white. Then the probability on this route from here to here is red as white, W, white, red. And the probability for this route for white, white is red as white, white. So this is how we represent this information on the actually what? On the tree diagram. Then we move to B. B was a different case because they said a bag contains 2 red beads and 3 white beads. A bead is picked at random from the bag and is not replaced in the bag. So here the bag wasn't replaced. So it is a different scenario. Then a second bead is picked from the same bag. Yeah, so solution. So here we are going to say in this scenario, after the first draw, the bead is not replaced. So the total number of beads in the bag decreases for the second draw. Yeah. So when one picks a bead from the bag and does not replace it, then you expect the total number of beads to decrease by 1. So the total number of beads is 5 actually. But if one bead is picked and is not replaced in the bag, you expect the total number of beads in the bag remaining is actually 4. Okay. So now when you do the second pick here, like then a second bead is picked from the same bag, you expect that the probability would have changed because the total number of beads for either white or red would have decreased. All right, and also the total number of beads altogether would have decreased because that first bead which was picked wasn't actually replaced. So we are saying for the first draw, there are 5 possible outcomes, 2 red and white beads. So for the first here draw, we know that the total or the possible outcome is actually 5 because at that particular time, the total number of beads was 2 plus 3, 5. Okay. Now for the second draw, there are 4 possible outcomes, which can be either 1 red and 3 white beads or 2 red and 2 white beads. Why? Because when the first bead was picked, it was not replaced. So we can assume that that bead can be a red bead. So if it is a red bead, then the total number of red beads would have reduced. Okay. Then also the total number of or the possible outcome also would reduce to 4. Because if you picked 1 red bead and did not replace it, since the total was 5 now, you picked 1 and did not replace it, then the total number or the possible outcome would reduce to 4. Then we are saying or 2 red and 2 white. It means here that in a scenario where the bead that was picked for the first time and not replaced was white, then the number of white beads would reduce to what? To 2, while the number of red beads remain 4. But when we add 2 plus 2, it will still be 4 beads. Okay. So this information can be represented on a tree diagram as shown. So for the first event or for the first picking, the ball can be or the bead can either be red or it can be white because we have red and white beads in the bag. So when you pick, we expect that you can either pick the red ball, bead, or the white bead. Okay, so the probability that this bead is red actually is 2/5 because you have 2 red beads and then total number of beads is 5. Then the probability that this bead is white is also actually 3/5 because there are 3 white beads and then the total number of beads is actually 5. Now this represents the first draw or the first pick. Now for the second pick here, then a second bead is picked from the same bag. It will come here. So here we can have 2 branches, okay? So here we have 2 where we are saying either for the second pick, either the second peak here can be either here we'll have 2 branches and here 2 branches, which means that for the second peak also the ball can either be the bead can either be red or white. Okay, and also here we are saying it can also be red or white. All right, now this is for the what? For the second draw, for the second peak. Now if this is for the second peak, what we should understand is that for the first pick, the ball was picked or the bead was picked and not replaced in the bag. So if we need to find the probability that it is red. So they picked a ball and did not replace it. So what is the probability that it will be red? So we know that if the ball was red here, since we are on the red branch here from here, we know that if the ball was red, the first one which was picked was red here. And then in the second pick, it was not replaced. Then the number of red beads decreases by 1. So you remain with 1. There were 2, and then you remain with 1. Now, since that first picking was not replaced, since the total number here was 5, now in the second pick here, where the first pick did not include replacing, so in the second pick which was done, since the first one was not replaced, meaning here the total number of beads will be 4. So in writing the probability, it will be actually 1/4. Okay, because if the first bid which was picked was red and then was not replaced, then the total number of bids then remain reduced to 1. And then also the total number of bids which was 4, since the first one which was red wasn't replaced, then it remains or reduces to 4. Now here on the white bid, it will remain the same. Since we are on the branch for red, if the first bid which was picked was red and not replaced, then it does not affect the probability of the white bid here. So meaning if the first bid which was picked was red, meaning the number of white bids still remains 3. However, the total number of bids has reduced also to what? To 4. Because that very red bid which was picked here and not replaced did reduce the number to 4. So here the probability that the white bid will be picked is still 3/4 because we assume that the first bid here was red. Coming to this again branch, it means that if for the first pick the bid was white and then it was not replaced, then this first pick just affected the white bid. Okay, the number of red bid still stays the same. If this first pick was white, then it affects the number of white beads. The number of red beads stays the same, which is 2. Now, since the white bead here was picked and not replaced, meaning that the total number of beads remains 4. So here we can have a 2/4, meaning 2 white beads and 4. Taking note or considering that here the probability, or here the white bead was picked and not replaced, so the total number of beads remains 4. However, since it was not a red bead because we are on a white branch here, then that the total number of probability, or the probability of picking here a red bead is 2/4. Now here the probability that of picking a white bead is going to be, actually here if they picked a white bead and did not replace it, then for the second time you pick a bead, and if it is white, then the total number of beads had remained to 2, and then here it would have reduced to what? To 4. So it will be 2/4 as well here. Okay, then the outcome here would actually be, on the red side here it will be red, on the red W it will be red, here it will be white red, and here it will be white. Okay, so let's move on to the second example, which says a box contains 3 blue marbles, then 4 red marbles, and 5 green marbles. A marble is taken and is not replaced, and then a second marble is taken. Okay, so the scenario is here we have 3 blue marbles, 4 red marbles, 5 green marbles. Altogether in total, if 3 plus 4, we have 7 plus 5, 12 marbles in total. But we're told a marble is taken and is not replaced, and then a second marble is taken. So, meaning if they pick the first marble and not replaced, it means the total number of marbles decreases to what? To 11. Okay, so that is what you should understand. Now here they're saying A, draw a tree diagram to show all the possible outcomes. Then B, find the probability of taking part 1, 2 green marbles, part 2, 1 blue marble and 1 red marble, part 3, 2 marbles of the same color, part 4, 2 marbles of different colors, part 5, no red marble. So let's start with the first part here, so which is A, solutions. So here what you should understand here is that for the first draw, there are 12 possible outcomes, 3 blue, 4 red, and 5 green marbles. Okay, then you must also understand that for the second draw, the number of possible outcomes decreases based on the color of the first marble drawn. So any member that is drawn or picked out of the bag or box, it means that the total number of members actually decreases from 12 to 11. So we are saying we can show the probability that the ball which is picked for the face is either blue or red or green here. So we can show either it is a blue or red or green. But what you should understand here is that this is for the first draw. So when you draw for the first time, it is either the member which is drawn or picked is either blue or red or green. Now, the probability that it is blue is actually, since we have a 3, so it will be 3 out of 12. 3 out of 12. The probability that it is red, since we have a red, it will be 4 out of 12. 4 out of 12. The probability that it is green, since we have 5 green members, it will be 5 over 12, like that. Now, we have done with the first pick. Now, for the second pick, awesome. If they picked for the second time here, we expect also either the member to be 3 possible outcomes there. Also, there are 3 possible outcomes here and also 3 possible outcomes here. So on the blue, on the red, on the green. So here it is either here blue or red, blue, red, blue, red, blue, red. I mean blue, red, green, blue, red, green, blue, red, green. So this is for the second draw, right? So now for the second draw, since the first pick or the first member which was picked wasn't replaced, so now the probability that for the second pick the member that is picked is blue is that since here the probability of the first pick of the blue is 3 over 12, it means that for the second pick, the number of blue members would have reduced because the first member that was picked, if it is blue and then it was not replaced, then the number of blue members in the box now will be 2. Then the total number of also members will not be 12, but it will be 11. So the probability now will be 2 over 11. Now the probability that it will be red is that since this first outcome here is only affecting the blue and not the red, it means that the total number of red members here is still 4. However, since here it only affects the blue ones, it means since the blue ones wasn't replaced, it means the total is 11. So here it will remain 4 over 11. Then here also it remains the same. So it will be 5 over 11 also, for the same explanation of given that since this one only affects the blue, meaning if the first one which was picked was blue, then for the second pick here, it will mean that it will be 5 green ones because the first one didn't affect the green, it was blue. Then since that first blue which was picked was not replaced, it would mean that the total number would have reduced to 11. Yeah. When we come here, we consider that this first pick was a red member. So if it was a red member, then it means that the probability for the second pick that the member is blue is that since this one only affected the red one, it means, and the red one was not replaced, it means that the red members actually reduced to 3, and then the total number of members also reduced to 11, I mean. So here it will be actually 3 over 11. When we come to red, so since this one affected the red member, so it means if the first draw or picking was for the red member and then it was not replaced, then the number of marbles actually remains now how many? Here, red marble, it remains 3. Now, since it was not replaced, the total number also remains 11. So here it will be 3 over 11. Now for the green one here, it means that since this first pick was for the red one, it did not affect the green. The green still remain 5. However, the total number of beads now is affected. It will be actually 11. So it will be 5 over 11. When we come here also, we know that this means that the probability, if the first peak of the bead was actually green. So now for the second peak here, since it is blue, we are looking at the probability that it was blue. The first peak means that it did not affect the blue one. It affected the green ones, okay? So it means for the second peak, you still have how many blue ones? They still have 3 there. But since if the first peak was green and then it was not replaced, it means that we still have 3 over 4 here. I mean over 11. Then here we come to here. Since also we are still maintaining that this probability here is for green, meaning the first pick meant that the bead which was picked was actually green. Then it does not affect actually the red picking, meaning the red still remains 4. However, the total number of beads reduces because if the first pick was for green and was not replaced, meaning the total number of beads reduces to 11. However, for the red one here, which is 4, it still remains 4 because this is for green. So it will be 4 over 11. Then for the green now here, if the first one which was picked was actually green, and then it wasn't replaced, it was picked, not replaced, meaning the total number of green remains what? 4. Again, since it was not replaced, the total number of beads remains 11. So it will be 4 over 11. Then we'll put outcomes here. We'll have here blue, blue, here blue, red, here blue, green, here red, blue, here red, red, here red, green, here green, blue, here green, red, here green, green. Okay. Yeah. So this is how we can represent this information on the tree diagram. Then we go to B. B here says find the probability of taking part 1, 2 green marbles. So 2 green marbles. So for 2 green marbles, what you do is you say, okay, the probability solution. So we answer from here. We are answering this one here. B part 2, that the probability that it will be green, it will be for the first peak, the probability is green, and for the second peak is green. So this G1 represents here the first draw here that the probability is green. Then also here, also it represents that the probability is green. Now you see where you can find green is here. So the probability that it is green, it is here. For the first peak, the probability that it is green is here. Then for the second peak, that the probability it is green is here. So these are what we call independent events. So independent events are multiplication. So we can say equals, we can say the probability of the first draw that the ball is green can be multiplied with the probability that the second peak the ball was green. So this is equal to this. Now we substitute the probability that on the first peak the ball was green is here. On the first peak or draw the ball was green is here. So you replace here, you put 5 over 12. So 5 over 12 then times. Then the probability that on the second peak here the ball was green is this one here. So you put 4 over 12, 11 I mean. Then you multiply 5 times 4, you get 20. Then 12 times 11, you get 132 so far. So you get 20 over 132 like that. Okay, so yeah, so here there's a mistake. Let me just edit this. Okay, so I edited. I said 5 times 4, 20, then 12 times 11, 132. Then we can say 5 into or 4 into 20. It can go there how many times? Actually 4, then 4 into that, I mean 4 into 25, then 4 into 132, it can go there 33. So the final answer can be 5 over 33. I've just reduced this to the lowest term. Then we move to part 2 of B here, which says we find the probability of taking one blue maple and one red maple. Okay, so here we are looking at the probability that it will be blue or red maple, which will be equal to the probability of picking a blue red plus the probability of picking a red blue plus the probability. Okay, so this is what this is it. So we're looking at blue red and blue red. So this can be written like this. So why? Because we will come here and see the outcomes. Blue red is here. Then we have another one, red blue here. Okay, because they're saying we find the probability of taking part 2, one blue maple and one red maple. So these are the ones that are giving us blue and red. So here we have blue and here we have a red. Okay, so this is it. And also here we have red and blue. So this is it. So there is no any other probabilities here or outcome here which can give us the result of one blue and one red. So here one blue, one red. Here also one red, one blue. They're the same. So you substitute here. So the probability that it is blue, red, you pick here, blue here, you get 3 over 12 here. Then you say times, then here blue, red, here coming to red here, it will be 4 over 11. Then plus this one here, you drop here. Then probability that it is red, you come here, red here, it is 4 over 12 plus or times. Then the probability here for blue is 3 over 11. Then you multiply like everything here. So these are fractions, so you get things like this. Okay. Yeah, let me just get back. So this will be your final answer if not mistaken. Let me just get my calculator so that I show you. Okay, so you're saying the answer is 2 over 11. So how do we get to 2 over 11? Because we evaluate this like here, 3 times 4, you get like 12, okay? Then over 12 times 11, you get like 132. Then there's a plus here. Then again, you say 4 times 3, it is still 12. Then over 12 times 11, which is 132. So these are fractions. So when adding them, you look for a common denominator, which is 132. You say 132 into 132, it will be 1. 1 times 12, it will be 12 plus. Again, 132 into 132, 1 times 12, it will be 12. So when you add them, you discover that 12 plus 12, it will give you 24 over, which is 132. Okay. Then you can further reduce. You say 12 into 1 into 24, it will go there how many times? It will go there 2 times, then over 12 into 132, it will go there 11. So this is how we got this answer here. Yeah. Then if we move to the second one here, which is 3. 3 says we find the probability of taking two members of the same color. So to answer this one, you must understand that the members of the same color in question here are actually these ones here. Let me just get my cursor here. So sorry, this is it. Okay, so the ones which are for red, because the question says find the probability of taking two members of the same color. So there's this one which can give us the same color, and also this one, and also this one, you see. So now how do we answer this one? So we can say probability of two members of the same color is going to be the probability of blue blue, and also probability of red red, and plus probability of green green, this and this, which will be equal to here. The probability here will be, for you to get a blue, this you multiply this probability and that, which will be equal to 6 of 132. How? Because we just picked this one here, which is 3 over 12 times this one here, okay, which is 2 over what? Over 11. So when you multiply 3 times 2, you get 6. Then 12 times 11, you get 132. This is where this one came from here. Then also this one here, you pick this one here, like this one times this one, which means that you have like let me put it here, like 4 over 12 times what? 3 over 11, which will give you what? 4 times 3, which will be 12 over this one, 132. So this is plus here, you drop it here, then you get this one 12 over 132, then plus, then this one also will involve for green, you get this one here, and also this one here on the path of green, which will be like 5 over 12 times 4 over 11, which will give you like 5 times 4, 20 over 12 times 11, 132. So this is how we got it, 20 over 132. So when you add these using fractions, then you are going to arrive at 38 over 132. If you reduce this one further, you get like 2 into 38, you get like 19, then 2 into 132, you get like 66. So this will be the probability of taking two members of the same color. Okay, so let me just clear this. Then we move to the third question or fourth question, which says two members of different colors. Okay, so we know those of different colors. We have this one here, we have this one here, this one here, this one here. These are of different colors. Or you can use this short formula. Probability of two members of different color will be equal to 1 minus probability of two members of the same color. So 1 minus that probability of the same color. So what you can do, you can say equals 1. The probability of the same color, which we have found here, was 19 over 66. So you can say equals, the final answer will be actually 47 over 66. So how? Because if you want, you can do like 1 minus 19 over 66. So this, you make it as a fraction as well. Common denominator is 66. So you say 1 into 66, 66. 66 times this one here to be 1 minus 66 into 66, 1. 1 times 19. Oh, here to be 66, I mean, because I said 1 into 66, 66, 66 times 1, 66. Then minus 66 into 66, 1. 1 times 19, 19. So when you subtract this minus that, you get 47 then over 66. So this is how we arrived on this answer here. But if you want, you can take the root here. Like, let me get back. If you want, you can do it in this way. So probability, you can equal here from here. You can say equals, you pick this one here, this one and this one, which will be a long root, of course. So you pick like this, this, okay, of different colors. You leave out those of the same color, like this one will be of the same color. So you pick which one, 1, 2, 3, 4, then also this one here, 5, 6. So there are 1, 2, 3, 4, 5, 6. So for this one, you are going to say 3 times 4, which will be actually 12 over 132. So say 12 over 132, then plus, then you come to this one, actually, this times this. So it's like this, or this times again this one here, which will be actually 15 over 132. So 15 over 132, then plus, then you come to this one here, which is 12, 4 times actually 3, which will be 12 over 132. So it will be 12 over 132 plus, then you get which one here, this one here, which will be actually 4 times 5, which will be 20 over 132. So 20 over 132 plus, again you pick which one here. So I've picked 1, 2, 3, 4. Yeah, so I have 1, 2, 3, 4. I'm here now. 1, 2, 3, 4, 5. I'm on 5 here. So I picked this one, 1, 2, 3, 4. Then I'm on this one here, 5. This one here, which is 4 times 3, 15. So it will be like 15 over 132 plus, then lastly, we are picking this one here, 5 times this one here, 420. So it will be like 20 over 132. So if you total everything like this one on top here, because these are fractions. So since, okay, sorry. So let me just do like this. Okay, so it's like I've made a mistake and rubbed everything which I had actually done here, but all in all, whatever I was trying to do, you can prove it. Like, you go with this one, this one, this one, this one, this one, this one. You total those probability the way I'm doing it, you still get the same answer. So this one is the shortest one. So we move to the next one. So the last one says find the probability of taking no red Mabel. So no red Mabel actually can be found from these probabilities here. So the probability of no red Mabel is going to be, this one here does not have a red Mabel. This one doesn't have. This one doesn't have. This one doesn't have. Okay, so meaning it will be this plus this one here. Okay, plus this one here. Okay, then plus this one here. Then you say equals, then for this one you get this times that, which will give you this. Okay, I've said this times this will give you this, plus then for this one here, you get this times this, you get that one. Okay, then for this one you get this times this, which will give you this one here. Then for this one you get this times this, which will give you this one here. Then if you total them together, you find that the answer will be 56 over 132. If you reduce to the lowest term, you get 14 over 33. Yeah, so basically this is how you answer questions on a tree diagram. All right, I hope you have understood this actually lesson. As see now, we can have the task here. So this is the task, guys, which can be done for you to understand how to answer questions on probability. As for now, bye and see you in the next lesson.